All right. So we just talked about a discrete random variable, and from a discrete random variable, we can have a discrete probability distribution function. Now, the form that our distribution function is going to take is going to be that of a table. All right, so we've got what you would call a discrete probability table. Okay, but technically it's called a discrete probability distribution function. Um, Now, for a random variable and a table to qualify as a distribution function, these following two conditions have to be true. So the first is each probability for each element of the domain of our random variable has to be between 0 and 1. And the second condition is that the sum of the probabilities has to add up to 1. So the sum of all the probabilities has to be equal to 1. And that's basically it. So in our previous example, we had a discrete probability distribution function, okay, which again takes the form of a table. And, here I had put that this was relative frequency, right? But this turns out to be the probability. And we can test and see whether this qualifies as a discrete probability distribution function. So all of the probabilities have to be between 0 and 1. So when you look at each of these, you can see each of these are between 0 and 1. So the probability for when the random variable is 0, that is a value between 0 and 1. So that's true. When the random variable is equal to 1, the probability is between 0 and 1. That's true. When the random variable is equal to 2, the probability is between 0 and 1. So that's true. When the probability of the last value in the domain is calculated, it's a value between 0 and 1, and that's true. So that satisfies condition 1, that each probability is between 0 and 1. And then finally, is the sum of all the probabilities equal to 1? So if you add all of these up, they will add up to 1. So that's true. So this table up above actually kind of qualifies this as a discrete probability function. And like I said, so another way to call it is a discrete probability distribution table. All right. So let's move on to this think, pair, share. So I'd say at this point, go ahead and pause the video, try this on your own, and then unpause and let's see how you do. Okay. So a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. So we have values of x. These are values of our random variable. And we have the resulting probabilities. So let's look at each of these parts to this question. So part A says, does this table of our random variable represent a discrete probability distribution function and why? So the first condition we have to look for is that is every probability of each element in the domain of the random variable. Let me write that a different way. Is each probability for every value in the domain less than or equal to 1, greater than or equal to 0? So if you look at each of these fractional values here, all of these are going to be less than 1. So this is going to be true. Then question 2 is, does the sum of all of these probabilities equal to 1? And so if you add 4 out of 50 plus 8 out of 50 plus 16 out of 50 plus 14 out of 50 plus 6 out of 50 plus 2 out of 50, then all of this, all of the numerators should add up to 50. Because all the denominators are the same, it'll be 50. And 50 divided by 50 is 1. So this ends up being true. So the answer, does this table of the random variable represent a discrete probability distribution function? The answer is yes. Okay, part B is describe the random variable x in words. So how was this random variable defined? Well, technically, random variable capital X is equal to the number of times the average post-operative patient rings the nurse in a 12-hour shift. All right. What is the domain of this random variable? So the domain of this random variable is between 0 and 5. So 0, 1, 2, 3, 4, and 5. What is the probability the number of times a patient rings the nurse is 4? So what we can do is we can come up here to our probability distribution function or table, and we can look here at this value of 4 from the domain of our random variable and come straight across, and that's our probability. So the probability that x equals 4 is equal to 6 out of 50, which comes out to 0.12 or 12.0%. There you go. All right, let's move on to part D, or E, sorry, part E. So what is the probability the number of times a patient rings the nurse is at least 4? So the hard part is trying to interpret what is at least means. So the probability that the number of times is at least 4. So this means it can be 4 or it can be greater than 4. Okay, sometimes you have to think about the English here. So what this would include, include when this would include the probability of the domain value of 4 plus the probability of the domain value 5. And this probability, which we had from the previous part, is 6 out of 50. And when x is equal to 5, that'd be 2 out of 50. And because these have a common denominator, we can add the numerators. So that'll be 8 out of 50, which is going to be 0.16 or 16.0%. So the probability that the number of times the post-op patient rung the nurse in a 12-hour shift was at least 4 is 16%. What is the probability the number of times a patient rings the nurse does not exceed 4? So the probability that the number of times does not exceed 4 could be less than or equal to 4. So that would be the probability of x equaling 0 plus the probability of x equaling 1 plus probability of x equaling 2 plus the probability of x equaling 3 plus the probability of x equaling 4. That's one way to do it, but I think a shorter way is we know that all of them have to add up to 1, and we could just subtract the probability that the number of times was 5. And let's say the probability that x is equal to 5, yeah, was 2 out of 50. So let's see here, 1 we can write as 50 over 50 minus 2 out of 50, which would be 48 over 50. And that comes out to, let's see here, what does that come out to? I'm getting a different answer. 0.96 or 96.0%. So this is the probability that the number of times does not exceed 4. Okay. Lastly here, what is the probability the number of times a patient rings the nurse is at least 1? Probability that it is at least 1. Very similar scenario. So this would be the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4 plus the probability that x is equal to 5. Or we could put 1 minus the probability that x is equal to 0. And what was the probability that x was equal to 0? 4 out of 50. So that would be 46 out of 50. And what's 46 divided by 50? 0.92 or 92.0%. There we go. All right. I think this is a good place to stop. Let me know if you have any questions.